Hi, I want to talk about the exception handling 7.4, and we're going to be using this in our programs moving forward. So the idea is if we are running a program, we have to think about what's going to happen in the future. So we can potentially have some bad data to come in. So if I'm reading from a file, I'm reading from the internet, I'm reading it from a database or the user, I can potentially have some issues, some problems, either from the data or some other things that's going on. And then first we have to detect what went wrong, and then we got to figure out what do we do with it. So first detecting errors, and then second is handling. So the goal always is I don't want to stop my program as much as possible. So if you guys are interested in a data science, you might get a lot of data, or you might have some sample, small data. So let's say right now we have coronavirus, and they are testing some people to see if the uh, medication they are creating is a good one or not. So if they have 250 people, and of course they don't make it very specific to person, they have to keep track of it. So if we are reading the data for 250 people versus 350,000 people, that's a big, huge difference. So if I have 350,000 records and one or even 10 of them are bad data, I'm just going to throw it away, just like they do it for voting. But if I have a small sample, 250 potentially is a small sample, I try not to throw anything away. So if I see a bad data, the question is, can I fix it? Can I put it as a default? Can I do something with it? Because the goal is to move forward. So, for example, I might have a field that's going to check for a gender, and the typical one right now, till we change it, is male, female, other. So if I get any character, maybe I change it to other, or I change it to something else, then I can move on. Uh, if it's a age, maybe I have a default age, or maybe I just leave it as a zero or something. So the goal is when I find an error, can I fix it and move on? Sometimes we can look at the data, and based on the data that's coming in, so let's say that I am doing image processing and I have a bad pixel. So I'm going to be looking at the pixels around it, and then I just fix that pixel based on what's around it. And that way I can move on. So that's what we're talking about, how to detect it and how we're going to handle it. But we have to, in design part, we have to think about what is it that we want to do uh, to, to move on. So first we have to raise an exception. So if something goes wrong and we find something is wrong, we're going to raise an exception. So for example, if you have a bank account and somebody is trying to withdraw some money that is higher than the money that they have in the bank, we're going to raise an exception. So we so we have a part that's going to raise an exception, and then we're going to catch it and we're going to do something with it. So we have a hierarchy exceptions that is this we have a lot of overlapping with Java on this thing. So we can use some of these things that's available to us, or we can create our own one. So first thing first is, okay, if there is an exception here and I see it and I can use this one, maybe I use this one. If not, maybe I create my own exception and then I'm going to handle it. So we are going to use the word raise to raise an exception, and we can potentially have a text in there. What's the message on it? And then what's happening is if we raise the exception, it's not going to come to this line. So the raise is going to just raise, basically it's going to raise its hand, and then we're going to catch it somewhere and I'm going to hand it. So whenever this happens, the next line or the next block is not going to be executed. It's just going to go. So when we are having an exception, we're going to figure out what is it we're going to do. Are we going to exit the program or are we going to correct the error? So the simplest lazy way is I see something wrong, I'm just going to get out. That's not a good plan. But if I'm trying to open a file and the file doesn't exist and I don't have a user to ask for a file name, then I cannot do anything. So I have to get out. I have to terminate the program. So even though we try to avoid this exit the program, sometimes we don't have a choice. We have to do it. If we have a user available, maybe we can ask some question or fix it. So we can put it in the try except. So we can put it in a block. So we can have a try block that we're gonna check this block of code, and then we can, it's going to raise the exception, and then we're going to catch it later. We're going to talk a little more about how we're going to do this. So we have the default ones. So for example, IO error is something that it's about the input output. So if this open doesn't find this file, it's going to raise an exception, which the IO error is going to catch. And this one is going to be like a generic one that we're going to be catching, and we're going to get the exception, and we can typecast the exception and see what kind of exception is this. But remember, if it does this one, it's not going to do this one. So we have to watch for the order. So let's go over this to see what's going on up here. So we have multiple things that's happening here. So in our try block, we have the open, which can cause the IO error. We have if we get the IO error, it's going to handle it in the IO error problem. Then we might have the int over here that we're trying to typecast something to the int, which doesn't work. It doesn't have, so it's a bunch of character. I cannot change it to integer. So we're going to get the value error exception that we can catch it and say something about it. So because we're making this, we're getting the object, and then we're going to be forcing the object to be a string, it's going to be writing the name of the object. And if it's not available, it's going to be something, not very user friendly. So we can have a friendlier message. So we can have a friendly message in there. We can create it. So we say if we have a value error, then we can have a more user-friendly string for it. We have something called the finally. Finally, if you guys coming from C++ 3A or 8, you see that over there a lot because C++ does not take care of memory management. It's a developer job to do it, but Python and Java, they do it. So we generally don't use the finally that much. So finally is going to happen no matter what happens. So if something goes wrong over here, maybe I just want to close the file before I get out. So that's the last thing I want to do. So in this case, the file, we open it up, the try block is for the write. So if this throws any exception, we're just going to close the file and we're going to get it. So this is something from software engineering point of view. This is not a Python thing. So the idea is we're going to throw the exception early, but we're going to catch it later. So what that means, we don't have to catch everything right there and then. So we can raise the exception and we can catch it in another place somewhere else. And we can put a bunch of them together and do that. So the tip basically says do not do it on the same block. We can put the finally somewhere else. And so, for example, we can have a try here and another try to do something else. And the finally would it be for this try to get the right issue as a result. And then we're going to catch the IO error somewhere else. So if I really want to close the file, if something happened with the writing, then I would do the try and finally inside another try. Because this happened a lot with our IO file IO, there is a shortcut with that that is a try and finally are together. So we can use the word with, and in that, it does both of them together. So we're going to use the with. That would be the try and finally together. That means if it doesn't open it, it's going to close the file and going to get out. So let's go over some of these examples that we have here. So we have a bunch of numbers that we are reading. And if we are reading some file, first of all, it might not, well, we're going to handle the input output file IO. And then when we get to the data itself, we're going to be validating our data. So you got to keep this in mind for your work that you're doing this week. So what's going to happen? So we are reading the goal is read a file of data values. First line is the count of values, and then remaining lines have values. So on the top, and this is some ways of doing the data file. So this is going to tell me how many lines do I have. So that's what it says. So if I add more lines, it's going to have more in it. So I know how many lines I have. So what can happen? Maybe I have more data than 3. Maybe I have less data than 3. So the question is what I'm going to do. If I have exactly 3 and it's all numbers, then I'm okay. But if I have 2 of them, then I'm missing a data. Then maybe something has to happen. If I have more, if I have 4, then I can potentially ignore the last after 3. I can potentially ignore it. So the question is what we're going to do. So the risk we are talking over here for this is the file may not be there. Then the open is going to raise an exception. So the file may be there, but we might have a wrong data format. So that can happen. So we can have a fewer data or we can have a more data. So we can have more inputs. And of course, we can have characters instead of the integers or numbers. So multiple things can happen over here. So let's see how we're going to handle this. So first, we're going to have a try. We're going to put these things together here. We can move them in different locations, but just for the practice for now. So the first one that we are thinking that's going to happen is my IO error. So that's where we're going to come down here with it for the IO. And then we can have a value error. So if I am expecting integer or a float and I'm getting character, I might have that issue with it. And then I might have a runtime error. So I might be dividing by 0 or doing something in that matter. So in this case, we're going to put the try finally here that we are reading the data, and if something goes wrong, we're just going to close the file and get out. So this is my function. Remember, we're going to put everything inside the functions so we can handle these things. So we can potentially raise an exception inside the function and let the function that's calling this one handle it. So if another function calling this one, maybe they can handle it. So for example, with the file name, I don't know if I have a user available or not. I just know that my file doesn't exist. So I'm going to raise a flag, but I'm going to let the calling function to decide if the user is there, they're going to ask the name of the file again. If they have some kind of a default file name, or they just going to close the whole thing and move on. So that's not my job in my function to handle that issue. But I know that I have to close the file and I open it, so that way I don't leave the file open. So if I have an int and I don't have the integer value, then I can have a value error. So that I can have it in multiple places. I might have extra data that I have to figure out what I'm going to do with it. And so if I have extra data, we're going to call the runtime error. We are using this one just for this. This runtime error is not exactly for extra data. We are just going to use this one and pass a string to print that one, so I don't have to create my new exception. So we have the main, and some of you guys don't do it in your assignments. Be sure that you have a main function on the top. The main has to be on the top, so we don't have to look for it. Everything has to be in functions. Everything you do has to be in functions. So your main is going to call the read file function. The read file is going to call the read data. The read data is going to call the typecast of the int. So we find out there is no integer, and we have the value error exception. But the read data might not handle it. So it's going to send it back to the calling function. And the calling function is read file, and read file doesn't have any way to know what to do with it. Then it's going to go to the top one, and then it's going to be handled over there. So I can go deep in the function and let the calling one to handle the exception. So that's what I have for you, and I talk to you later.